Hi, today I'm going to explain Newton's 3 laws with LEGO. Newton's first law says that objects that are at rest will remain at rest unless acted upon by a force. So what does this law mean? Well, in order for an object to be stationary, it has to have zero net force. Net force is the sum of the other forces in the x or y direction. But Newton's law states that when this object that is stationary is interrupted by another object with a greater force, that stationary object will now move. Here's an example of that. In this case, Tianman was at rest, but I changed that by being the uneven force that crashed into him. Now I will give an example of his second law. The second law states that force is equal to the mass times acceleration. So first, let's talk about how mass times acceleration will equal force. The units of mass in kilograms times the units of acceleration, which is in meters per second squared, will give you the unit of newtons. Newtons is the unit that we use to measure force. With the equation force equals mass times acceleration, we can find out all sorts of measures. Like, if we are given acceleration and the force, we can find the mass of that object by dividing acceleration from the force and isolating the mass. It's simple algebra. Let's try it out. In this example, the acceleration of the car depended on how much force I used to push it. If I used less force, it would accelerate slower. If it had more mass, I would also need to apply more force. Now finally, Newton's third law of motion states that for every action there is an equal and opposite reaction. To demonstrate this, I have my hand on this wall. My hand is applying a force to the wall, but the wall actually exerts an equal amount of force back on my hand, or in the opposite direction. And that's Newton's 3 laws, but in LEGO. Thanks for watching this video. Whether you were here to learn physics or just wanted to watch some fun LEGO animation, or you're my classmates and teacher who are currently watching this in my physics classroom, I appreciate you being here. This video took lots of work and was super risky in being my final for my physics class because I had no clue how long this would take to render, but ultimately, it worked out in the end.